for those that want to look at this last example. Okay, again, something that I have not done ever before. So when I look at it, I'm thinking, I don't like either side, but I think that I maybe could do more with this side. Okay, I see I could maybe use the quotient identity a couple times possibly, and this I could change the reciprocal function. Okay, so that is why I made my decision here. I'm not sure I could change this to 1 minus sine squared theta, but then what do I do after that? So I'm going to, as I said, start with the left side. All right, so let's see what we got here. All right, let's try, I'm not sure what color, we'll do green. Make life nice. And green. All right, so I decided I'm going to choose the left side. And over here is my reasons. For some reason, I don't have that set up just right. And again, I put a line down between the two. So I'm starting with tan squared theta, or x, theta x, same thing, plus 1 plus tan x secant x. Now, actually, as I wrote that down, I'm thinking, I wonder if I could factor something out. I maybe could, but I think that might be a little bit too much for me right now. So the first thing I'm going to do is I'm going to replace with the identities that I can. So the first one would then be sine squared x over cos squared x. I'm going to leave 1 the way it is for now. The tan, again, I'm replacing it to sine x. Oops, sorry, that's plus. Sine x cos x. And while I'm at it, I'm going to change the secant to 1 over cos x. So I've done a lot of substitution with my basic identities. So I've done the quotient twice, and reciprocal identity. Now, when I look at this, I'm not quite sure what I want to do. So I think I'm going to multiply this together. So I would have sine squared x over cos x, cos squared x. I'm going to leave that 1 alone again, but I have a feeling I'm going to have to do something with it shortly. When I multiply these two together, I end up with a sine x over cos squared x. And so what we did there is all we did was multiply. Now I'm going to stop and I'm going to look now to see, remember, this is the side I want to get. Notice there's a cos squared x. I almost have everything with a cos squared x. So I think what I'm going to do for this one is I'm going to make a common denominator for it of cos squared x. So that's the next step I'm going to do. So sine squared x. So everything here is going to be over cos squared x because that's our common denominator. So the 1 then will be plus a cos squared x, because cos squared x over cos squared x is 1. And we still have our plus sine x. So all we did there is we found a common denominator. So common denominator. And again, I'm looking now, at least I have the bottom the same as the other one. Now, if I look here, I need to have 1 plus sine x. I still have a cos squared x. So I somehow have to get rid of that. Now the only way, if I look at my substitutions, the only way that I see a cosquared x has to do with the Pythagorean identity. Okay, so I could change cos squared x to 1 minus sine squared x, or I could take the sine squared x and this cos squared x and change it to 1. So if you look at the right side, if I change these two to the number 1, I actually have them the right side. So actually this one didn't take us as long as that previous example. And the reason I could do that step was the Pythagorean identity. Which now equals my right side. Therefore, and I'm just going to have to move that down a little bit in order to get it. Therefore, tan squared x plus 1 plus tan x plus 1 plus tan x secant x equals 1 plus sine x over cos squared x. Okay, so hopefully these last two questions gives you kind of an idea of the problem solving that goes on in even a teacher's head that hasn't seen anything before. Okay, so when obviously the questions that you have from your textbook are not going to be most of them aren't near as complicated as the last two. However, you can expect that your assignment will have that you actually have to do some thinking because this is your thinking mark for this unit. Okay, have some fun.